What's up? What's up? It's your man, Jimmy Chan. All right, so we're talking about polynomial functions here, right? Polynomial functions you've seen before. You've seen quadratics before, where it's like f of x is equal to x squared, or you know what? I should do it this way. Ax squared plus bx plus c, right? That's a quadratic because the power is a 2. You've seen it where, you've seen f of x is equal to ax to the third plus bx squared plus cx plus d. That would be a cubic because the power is a 3. Now, it can go as low as f of x is equal to mx plus b. Well, that is a linear, and the power here is just a 1, right? And then you can also go to as low as f of x is equal to like 5, because we have x to the 0 power, and the degree here is 0, right? Those are all so-called polynomial functions, all right? Now, all this is saying is, all this is showing is that as you look at all of these are terms when you put in standard form that your largest power goes first, and then your next lowest power and your next lowest power and so on. And then all the way down to a constant. And this constant typically has x to the 0 power, where x to the 0 is known to be as 1. So 1 times anything would be itself, so x to the 0. So again, anything in front of that x, those are called coefficients, all right? And the term that has the largest power, that coefficient will be considered a leading coefficient, all right? And the degree of the polynomial is based on the largest power, okay? So whatever the largest power is your so-called degree of the polynomial. So for example, when I said y is equal to ax squared plus bx plus c, right? Since the largest power is a 2, then the degree of the polynomial is a 2. And if it was a cubic, then the largest power is a 3, so therefore the degree of the polynomial would be a 3. Now, what I want you guys to notice here is that what this is saying. This is saying that all the powers or exponents have to be positive or equal to 0, and it has to be an integer. So it can't be negative, it cannot be a fraction, it cannot be a radical, all right? It has to be an integer, and it has to be positive or 0, okay? Like I showed you over here, this is x to the 0, so that is legal for that to happen, okay? Now here's some examples here as I was showing you guys, to the side, is that if I have y is equal to 0, that's a 0 function. And if the degree is 0, then it's just a constant, right? Like x equals 5. If it's the first power, then it's kind of like y equals mx plus b. If it's the second power, then it's a quadratic where the largest power is 2. All right. So here's some examples for us to identify if some of these are so-called polynomial functions or not. So this first one here, since it's a fraction, is not a polynomial function. Okay, since it's a fraction. Okay, this second one here is also not a polynomial function. And why is that? Because it's a radical. Okay. The next one here is, it never said anything about the coefficient being a fraction. It's just saying the polynomial being a fraction. All right. So here we are in standard form from the highest to the lowest power. So here the degree is a degree of 3 because the largest power is a 3. okay? And the lead coefficient would be a 4. And the constant is a -7. Okay, so we can see that. Let me see. Oh, you know what? Let's stay with the red. So we got the 4 and we got the -7. Okay, so that's where you see all of those. Now, how about this one here? Well, that is actually a polynomial function, even though we don't see any x or any powers or anything like that, right? In this case, remember that this can be written as x to the 0 power, right? So it's because x to the 0 is 1, 1 times 9 is still 9. So therefore, the degree is actually 1. And since that's the highest power, the lead coefficient is actually 9. And the constant, since this is the only number it is also 9. All right? So let's take a look at the next one here. The next one here is not in standard form. So we might want to go ahead and write this in standard form first. And then those two are like terms, so let's go plus 4x. Okay? And if that's the case, then I can come back up here and grab this. And now we can look at the degree is a 4, because that's the largest power. The leading coefficient is -5. And the constant is going to be 0 because there's nothing here, right? So it would be a 0. It's not just the last term, but it is 0. And we usually don't write plus 0 anyways. So here, what we have to do is actually work this out to see if, what it actually is. So what we can see is that I can tell the degree by looking at the powers, right? So here's x to the 3rd, and here's going to be x squared. So I know that the power is going to be 5, or the degree is going to be a 5. However, the rest of the stuff, we're going to have to kind of work this out to look at it. All right, so let's say h of x is equal to -x cubed. And let's go ahead and FOIL this, or double distribute, of course. And that's going to give me a x squared minus 6x plus 9. And when I distribute the x cubed through, I'm going to have h of x is going to equal to -x to the 5th plus 6x to the 4th minus 9x to the 3rd. So now let me go ahead and bring this over. Now we can see that the degree is 5. The lead coefficient is going to be -1, and the constant is going to be 0 because there's no 0 here. I mean, there's no constant here. This is the power, and this was the lead coefficient. Okey-doke. All right, so the other thing you need to know about polynomial function is that it's going to be nice and smooth, okay? Where if it's not a polynomial function, then you're going to see like corners or cusps or gaps or holes. If there are those, then it's not a polynomial function. But other than that, it is a polynomial function, okay? And what you're going to start to learn, well, we'll keep on going. So if the power of the polynomial function is even and is a positive even integer, okay, then what you will see is that if it's even, you're going to have n behaviors that are going to look something like this. Okay, meaning as I go to positive infinity on the x, my y value is going to go to positive infinity. And as I go to negative infinity on the x, my y value is also going to go to positive infinity. This is also be considered the end behavior of the graph, okay? And if the power of the function n is actually odd and positive, then what you'll have is you'll have something that looks like this when it goes. I should probably bring this up. It's going to be when it goes to positive infinity on the x, it's going to go to positive infinity on the y. When it goes to negative infinity on the x, it's going to go negative infinity on the y. So again, as it goes to positive infinity on the x, it's going to go to positive infinity. As it goes negative infinity, it's going to go negative infinity. Okay, so it's kind of going in opposite directions, right? So that is also known as the end behavior. Okay, so when you get, if we go back up here, because this is even, we know that the end behavior is going to go something like this. We don't know what happens in the middle. We just know that the end is going to both point up. And over here, now this is a negative, but this is odd, right? So since this is odd, that means my end behavior is going to go opposite direction like this, right? However, it's negative in front, right? The a is negative, so that means what will happen is that this is actually going to go the opposite direction. So this is not going to go this way, it's going to actually go this way, okay? Because the negative here actually flips it over the so-called x-axis, all right? So that's what's actually going to happen there. Oh, same thing here, I guess, right? So because this is negative, it's actually going to go this way. So I guess it would be good to actually draw this out this way just so that you guys can see what the end behavior is going to be, all right? Where this one here, because it's positive a, then my end behavior is going to do this, okay? See the difference here of this one and this one? As x goes to positive infinity, it goes to positive infinity, negative infinity, negative infinity. Positive infinity, negative infinity, negative infinity, positive infinity. Okay, totally opposite. All right? All right. So let me see here. All right. So real zeros. So to get these spots right here, let me go ahead and circle them. Now notice what I just did. I circled this one a little differently, didn't I? All right, so let's take a look. Number one, what we know is that what I just circled in red and in blue, those are called X-intercepts, right? We know X-intercepts is when y is equal to 0 or f of x is equal to 0. What else do we know? We also know that these are not just called X-intercepts, it's also called roots, and it's also called zeros. So it's some other names, okay? So if I just take the function and set it equal to 0 and find the x's, I'll find all 4 of these points, okay? So that's number one. So why did I circle them differently? Now, if you notice that here, it goes through from negative y value to a positive y value. It goes through the x-intercept. This also goes through the x-intercept. This also goes through the x-intercept. However, this one here does different. It kind of bounces off the x-intercept, right? So there's something special about this one. So what I'll tell you is this. Let me put it this way. Let me draw an arrow here. Draw an arrow here. And draw an arrow here. Okay, so all 3 of these has, I don't know how it came about that. These are going to be zeros with odd multiplicity. Okay, so these are zeros with odd multiplicities. Okay, and this one here is going to be a 0 with even multiplicity. Okay, so you got it gets kind of a little confusing because number one, right? Because of the end behaviors, we have even and odd, right? Of the power. And then down here we have even and odd with the zeros as well, right? So we got even and odd, not just with the power, but we also have even and odd with the zeros. So that's why those things are kind of confusing sometimes, right? So actually, let me do this because this might be something we need to kind of do here. Bring this all the way up here. Okay, because what I want to do is, maybe I'll use purple. See how this arrow here and this arrow here are pointing in opposite directions, and as we know, as this is going to positive infinity on the x-axis, this arrow is pointing to positive infinity on the y-axis. So this arrow here is pointing to the positive x and positive y infinity. And this is pointing to negative infinity and negative infinity on the x and the y. When that is the case, then we know that the power is odd and the A is positive. Okay, the A, the coefficient, okay? A is positive. So again, you guys have a lot to work with, I know, right? So even and odd with multiplicity because of the zeros. We have even and odd with the powers, right? And the A is positive or negative and so on and so forth. So this graph right here showed a lot, all right? And then the other part is that they're going to talk about turning points. 1, 2, 3, 4 turns here, right? So this is actually going to be a power of 5, all right? And we'll talk about that in a little bit. So these are the things that I just talked about, real zeros, right? That the x is, it's the x-intercept, and if it's r, then x minus r is a factor, right? So for example here, let's continue on. We'll talk about that more as we go. So, all right. So for this example here, is find the polynomial, and this would be a good example of what it means by x minus r as a factor. So find a polynomial function of degree 3 whose real zeros are -1, 2, and 3. So what does that mean? That means that the real zeros, which is the x-intercepts, is at -1. So that means x is equal to -1. So what would I typically do? To go backwards to find the equation, I would bring the -1 over to the left side with the x. So I'll have x plus 1 is equal to 0. And then it says that it's also 2, so I got x equals to 2. If I bring 2 to the other side, it would be x minus 2 is equal to 0. And it's also 3, so x is equal to 3. So x minus 3 is equal to 0. If that's the case, then I can write factors of x minus 3, x minus 2, and x plus 1. So if I multiply those together, I will also have some kind of third degree polynomial. However, the only thing that's missing is an A, because the A always needs to be there, because the A is what's going to kind of show me if it flips over the x-axis or not, if it's going to compress or stretch or anything else. So we'll say that the f of x is going to equal to this particular equation, okay? So anytime it tells me it's a real zero, this would be the process that I go through, all right? In this example, it talks about the multiplicity, as I was talking about before on that graph, right? So if I was to set this equal to 0 and looking for zeros, right, I would just take this and say, okay, I have 6x to the third times x minus 5 times x plus 1/4 to the fourth, and say that is equal to 0. Then I'll set each factor equal to 0. So I'll say, okay, 6x to the third is equal to 0. Solve for x. X is going to come out to be 0. I'm going to set x minus 5 equal to 0. Then x is going to equal to 5. If I say x plus 1/4 equal to 0, then x is going to equal to negative 1/4. Right? All right, with that being said, you can see my real zeros are at 0, 5, and negative 1/4. So it says 0 is a real zero, right? 0 is a real zero. With a multiplicity of 3, because this is x to the third power, so it has a multiplicity of 3 because the exponent is 3. So it means that this is odd. That means this is going to go through the x-axis. I mean, the x-axis or x-intercept. I just don't know which way it's going to go. Is it going to go from top to bottom or bottom up to through the top, right? Over here, it says 5 is a real 0. I can see that 5 is a real 0 with a multiplicity of 1 because the power here is to the first power. All right, so that is also odd. So the same thing that happened here is going to happen here as well. Okay, I guess I should put it over here. Maybe that'd be easier if I just did that. Right? I just don't know which direction. Now, over here it says negative 1/4 is a real 0. Notice it says negative 1/4 right here. So negative 1/4 is a real 0 with a multiplicity of 4. See this right here? The power is 4. So the exponent, because the exponent of x plus 4 is 4. All right, so that's why that is. But however, that it says it's even. That means this is going to actually bounce off of it's going to bounce off of the x-intercept, except I don't know which way it's going to bounce off of, right? I don't know if it's going to bounce off that way or this way. It's from above or from below. That I'm not really sure of, so I'm going to have to kind of look at the graphs. And as we go, when you guys start graphing these, you'll start to see, yes, it has to bounce off from the top or bounce off from the bottom, okay? So this is what it's going to say right here, right? So if the real 0 is even, then it's going to touch, right? It's going to touch the x-axis, okay? Which is the same thing as what you see right here, okay, doke? And then here it says if the real 0 is odd, then it's going to cross it. Well, it crosses just like something like this here, okay, where it's just going to go right through. Okay, doke? All right, so let's continue on. Turning points. So if a polynomial function of degree n, then the graph of f has at most n minus 1 turns, okay? So if I have f of x is equal to x to the 5th, right? And if I take that 5 and subtract 1 is equal to 4. So x to the 5th will have at most 4 turning points. Okay, so there should only be 4 turns altogether, right? And then we can always work backwards, right? So if it was 4, just say n minus 1 is equal to 4, and then you can just solve for n that way, and you'll know that the power is 5. So it's a power minus 1, okay? All right, so over here, let's identify. So since there's a gap, this is not a polynomial function, okay? Over here, everything's smooth, no sharp edges, no cuts, nothing, so this is good, all right? So what do we know? I got 1, 2 turns, so since I have 2 turns, that means the degree is a 3. I know that my x-intercepts, or zeros, are at -3, -1, and at 1, and they're all odd because look, it goes through, goes through, goes through. And I see a y-intercept as well, right? So I know also my y-intercept is at 0, -3. Okay, so there's a lot of information right here on the graph that we're given. Okay, over here, because of this cusp right here, this is also not a polynomial function. And then over here, we have over here, we have 1, 2, 3 turns, right? So 3 turns. That means this is going to have a degree of 4. I see that my zeros are at -3 and 0, and they're both odd because they both go through it. Nothing bounces off, okay? All right, so this is now talking about the end behavior as I was showing you guys here, because the end behavior is both going to positive infinity as it goes to positive infinity, negative infinity as it goes to, positive infinity when it goes into negative infinity. That means this is going to be even, and the a is going to be greater than 0. Over here, because it's both pointing down, it's still going to be an even degree, but it's going to be pointing down. So that means a is going to be negative. Okay, so this is essentially what this is saying here, but let's go ahead and write it anyways. So degree even, a is positive. Degree odd, negative a. Over here, because as x goes to positive infinity, y goes to positive infinity. As x goes to negative infinity, y goes to negative infinity. I know that this is degree is odd. Oops, sorry. This is supposed to be even. This degree is odd, and a is positive. And since when this x goes to positive, as this x goes to positive infinity, that y goes to negative infinity, and as x goes to negative infinity, y goes to positive infinity, then I know that this degree is odd. But it has a negative a, okay? All right, so which graph is possible for this? Okay, so the function is x to the 5th, blah, 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 right? So number 1, we know that, so turns. or turning points, right? Turns would be the 5 minus 1, which is equal to 4. So there should be 4 turns. Okay, 1, 2, 3, 4. Check. 1, 2, 3, 4, 5, 6, 7. Oh, no good, right? Too many turns. Okay. Let me see here. 1, 2, 3, 4. Check. How about over here? 1, 2, 3, 4. Check. All right. So that checks off in terms of turning point. I got 3 of them and eliminate 1 of them. Okay. Let me see. I know that A is positive, right? Because this is a positive 1. So A is positive. Actually, let me just do it this way. Since it's positive, and, well, let me do it this way, actually. N behavior. So degree is odd. So it should go, and is a positive A, so I should see this and this. Okay? So as x goes to positive infinity, y goes to positive infinity. As x goes to negative infinity, y goes to negative infinity. So let's see here, which one point has n behaviors like this. So over here, oopsies, is going in the wrong direction. So therefore, this is no good anymore. Over here, it is in the right direction. And here is also in the right direction. All right, so we eliminate another one. Okay, what else do we know? Well, if I was to look at, let's say, the y-intercept, I know that x is equal to 0. So if I plug in 0 in for all of these, those will all become a big fat 0. So the only thing left would be 3. So that means I'll get y is equal to 3. So I should have the point 0, 3. So looks like this is the only point that has a 0, 3. So this is no good. So this must be my answer. Okie doke. All right, let's continue on. So it says find the polynomial function whose graph is shown using the smallest degree possible. Okay, so let's take a look here. What do I have? So if I was to look at this, what I can say is a couple of things. Number one, I see this right here, right? This is telling me that x is equal to -1. So I bring the -1 over, I got x plus 1 is equal to 0. This one right here, oh, not just that, I forgot this too. And this is also even because, notice this bounces off, right? It bounces off, so I know that the multiplicity is even, okay? And the smallest even number I know is going to be a 2, right? This one right here is x equals 1. So if I look at that, x equals 1. If I bring the 1 over to the other side, I got x minus 1 is equal to 0. And this one is going to be odd because it goes right through it, okay? Because it goes right through it. Let me see if I can actually... It's all right. So, and the smallest degree that I know of that's odd is going to be to the first degree. And then this one here, that's going to say x is equal to 2. So I got x minus 2 is equal to 0. And since it goes through it, that means I know this is also odd. So this is going to be the smallest odd I know is going to be to the first degree. So again, this wants the smallest. That's the reason why I'm doing that. all right? Oops. So with that being said, a good start with my equation is going to be f of x is equal to x plus 1 times x minus 1 times x minus 2. However, what I need here is the a. I gotta find out what. So that is what's gonna help me with this piece here, okay? This piece tells me that I have a point of 0, 4, right? What does that mean? That means, hey, f of 0 is equal to 4. Okay, so let's go ahead and plug that right into this equation here. So f of 0 is equal to 4, so 4 is equal to a times 0 plus 1. Oh, forgot the square, guys, because remember we said this was even, right? And then times 0 minus 1. And this is to the first power because we said odd, and the smallest odd number we know is 1. So this is only to the first degree. And then this right here, same thing, 0 minus 2. And this is also to the first degree because we said it's odd as well. Okay, so if we do this, if we work this out and multiply these three numbers together, we're going to have 4 is going to equal to 2a. So a is going to equal to 2 when I solve that. So my equation is going to be f of x is going to equal to the 2 times the x plus 1 squared times the x minus 1 times the x minus 2. So that will be my equation. And there you go. I hope that helps. If there's any questions, let me know. See ya. Bye.